Good evening, students. Today we are going to discuss further determinants chapter. Now, further our topic is properties of determinants. So, first of all, today we are going to discuss the properties of determinants, right? So, first property says the value of a determinant remains unchanged if its rows and columns are interchanged. So, if I take one matrix A and I take its determinant, that will be equals to the determinant of same matrix when rows and columns are interchanged, right? Now when rows and columns are interchanged, that means what? That means the transpose is being taken. So now whenever we will take the transpose of any matrix, its determinant will remain the same. So that will imply determinant of A will be equals to determinant of A transpose, right? Now we can have any of the example and we can check this property that determinant of A matrix will be equals to determinant of A transpose, right? So now let me have one example which says let A be equals to 2 3 5 7, and they said check the property 1. That means whenever we will change the rows and columns, the determinant will remain same. That is, the determinant of A matrix will be equals to determinant of A transpose. So first of all, check the determinant of A. As you all know how to check the determinant of 2 cross 2 matrix, you have to multiply the diagonal elements, subtraction of you have to multiply the main diagonal elements and then subtraction of the other diagonal elements product from the main diagonal elements product. So you will get 2 into 7 minus 5 into 3, which will be 14 minus 15. So it will be minus 1. Now do is what? Now take the transpose of that matrix. That means interchange the rows and columns. So you will get A transpose as 2, 5, 3 and 7. 2, 5, 3 and 7. Rows are becoming column and column are becoming rows. So now take the determinant of A dash. A dash means A transpose. So determinant of A dash will be what? Determinant of 2, 5, 3 and 7. So now multiplication of main diagonal elements, subtracting the multiplication of other diagonal elements, right? So 2 into 7 minus 5 into 3. So we will get 14 minus 15, which will be minus 1. So property 1 holds true. So this you can check for all of the matrices, any of the matrix, right? So any matrix, if we change the rows and columns of that matrix, the determinant remains same. That means the determinant of A transpose will be equals to A, right? The determinant of any matrix will be equals to its transpose determinant, right? Now moving on to the second property. Second property says if any two rows or columns of a determinant are interchanged, then the sign of determinant changes. If I change the rows and columns, interchange the rows and columns, any two rows and columns, not now whole means taking the transpose. Now we are doing is what? We are interchanging two rows or two columns, right? Now what they said, the sign of the determinant will change if we will do so, right? So now delta 1 will be equals to negative of delta, where delta 1 is the determinant after change and delta is the determinant before change. Now let us check this property by one example. Example says verify property 2 for delta equals to 1 2 3 4 5 6 7 8 2. Now how to find the determinant of a 3 cross 3 matrix? You all know this is the procedure. 1 into determinant of 5 6 8 2 into minus 1 power odd, no, even 1 plus 1, which will be 2, right? Even. So 1 minus 1 power even will be 1. So I left out that. Now plus 2 into minus 1 power odd, which will be 1 plus 2, right? So minus came forward and deleting the rows and columns, you will get 4 6 7 2 into determinant of 4 6 7 2, and then plus 3 into minus 1 power even 1 plus 3, which will be plus 1 only. So 3 into determinant of 4 5 7 8 obtained by deleting third row and first row and third column, right? Now solving this, we will get the determinant as 21. We got the determinant as 21, right? Now we are doing is what? We are interchanging row 1 and row 3. Now firstly our row was 1, 2, 3, right? Row 1 was 1, 2, 3. Now our row 1 is 7, 8, 2, and row 3 is now 1, 2, 3. Earlier it was 7, 8, 2. So now row 1 and row 3 are interchanged and row 2 remains same. Now we are finding the determinant, right? Expanding along row 1 only, right? 7 into minus 1 power even, so plus 1, determinant of 5, 6 and 2, 3, right? Minus 8 times, why minus now? Because minus 1 power odd, which will come as minus 8 times determinant of 4, 6, 1, 3, obtained by deleting second column and first row, plus 2 times minus 1 power even, which will be positive, so it remains as it is, into the matrix determinant of matrix 4, 5, 1, 2, obtained by deleting third column and first row. So this gives us the determinant as minus 21. As we can see, the sign of the determinant is changed whenever we interchange the two rows or columns. So this type you can do the columns as well. You can interchange any two columns and check that the sign of determinant changes, right? Next, third property says if any two rows or columns of a determinant are identical. Now identical means all the elements are same, right? Identical means all the corresponding elements are same, right? Then the value of the determinant is 0. If two rows or columns are identical, right, then what? Then determinant will be 0. So let us take one example. Suppose A is 1, 2, 3, 1, 2, 3 and 2, 5, 6, right? Now you can see two rows are identical. That means by the property determinant of this matrix must be 0. Now they are saying show that determinant is 0. Now expand the matrix, expand not the matrix determinant, right? So we will get 1 into determinant of 2, 3, 5, 6 obtained by eliminating first row and first column, minus 2 times determinant of 1, 3, 2, 6, right, obtained by deleting first row and second column, plus 3 times determinant of 1, 2, 2, 5 obtained by deleting third column and first row, right? So solving this, simplifying this, we will get at last the determinant equals to 0. So this says property 3 holds very true. So this properties holds for every matrices. These are the general properties, right? So these are not particular. These are the particular examples that we took, but these properties hold true for any matrices, right? So these are general. So this was our today's topic. Next properties we will discuss tomorrow in the next video, and problems based on this we will discuss in the class. Thank you, and we'll meet you in the class. See you soon. Take care.